Somewhere between 5 and 7,000 years ago, something happened to human men that sounds like a bad horror movie premise. Not a plague, not a war that anyone wrote down, not an asteroid, just a slow, quiet, genetic disappearing act. And when scientists finally noticed it, buried inside our DNA like a fingerprint smudged onto a windshield, the number they came up with was so strange that some of them assumed they'd made a mistake. The ratio was 17 to 1. 17 women reproducing for every one man. Sit with that for a second, because your brain is probably doing the same thing mine did the first time I heard it, which is trying to round it down to something more comfortable. Maybe it was 3 to 1. Maybe 5. Surely not 17. But this isn't a rumor from a forum, and it isn't a wild guess from some guy with a podcast microphone and a theory. This is what population geneticists found when they compared two different kinds of DNA that get passed down along two completely different family lines. And when the numbers came back, an entire field of scientists spent years arguing about what could possibly explain it. So today we're going to answer the question that title promised you, but we're going to answer it properly, which means we're not just going to throw a number at you and walk away. We're going to figure out where that number comes from, why it's almost certainly not what you think it means, who the actual record holders were, and why the answer changes depending on whether you're asking about a farmer in Mesopotamia, a warlord on the Mongolian steppe, or some guy hiding in a cave 40,000 years ago just trying not to get eaten. Stick around, because the twist at the end of this one is one of the wildest things I've ever learned about human history. And it involves warfare, inheritance, and the uncomfortable realization that a huge chunk of the men who lived and died on this planet may have left absolutely nothing behind. Not a name. Not a grave. Not a single descendant. Nothing. Let's start with the DNA, because that's where this whole mystery began. You have two kinds of genetic material that tell very different stories about your ancestors. There's your Y chromosome, which passes almost unchanged from father to son to grandson, generation after generation, like a baton in a relay race that only men get to run. And there's your mitochondrial DNA, which passes from mother to child regardless of gender, but which only gets carried forward by daughters going into the next generation. Two separate lineages, two separate records. One tracks the men, one tracks the women. Now here's where it gets interesting. If you map out how much genetic diversity exists in each of those two lines across modern populations in Africa, Europe, and Asia, you'd expect them to look roughly similar, because on average roughly the same number of men and women should have been reproducing throughout history. Give or take, nature isn't usually that lopsided, except the Y chromosome tells a completely different story than the mitochondrial DNA does. Starting somewhere around 7,000 years ago, the diversity of the Y chromosome basically collapses. It doesn't gradually decline. It falls off a cliff, and it stays low for about 2,000 years before things start to normalize again. Meanwhile, over that exact same stretch of time, the mitochondrial DNA just keeps climbing steadily upward, like nothing happened at all. Translation: the number of women contributing to the gene pool kept growing the whole time. The number of men contributing to the gene pool crashed. And this wasn't a one-off blip in a single village somewhere. This shows up in Africa, it shows up in Europe, it shows up in Asia. Different regions, different timelines, slightly different intensities, but the same basic pattern over and over again across 3 continents. When researchers first published this back in 2015, the estimate that came out of the math was that the effective male population had shrunk to something like 1/20th of what it used to be, which is how you end up with headlines describing it as 1 man for every 17 women. Now, before your brain runs off and builds an entire fantasy scenario involving some ancient civilization that decided to just start killing off 95% of its male population, let's slow down, because that is almost certainly not what happened, and the actual explanation is honestly more interesting than a straightforward massacre. The first thing to understand is that 1 man for every 17 women does not mean there were literally 17 times more women walking around than men. Populations don't work like that. Men and women are born at roughly the same rate in every generation, always have been, always will be. Biology doesn't play favorites at birth. What this ratio actually measures is something called effective population size, which is basically asking a different question. Out of everyone who was alive, How many of them actually managed to have children whose lineage survived all the way down to today? That's a completely different question than how many people were alive. And once you frame it that way, the picture starts to make a horrifying kind of sense. Picture a village. Plenty of men living in it. Plenty of women living in it. Roughly equal numbers, same as always. But if only a small handful of those men are the ones fathering children who survive, marry, and have children of their own, generation after generation, while the rest of the men either don't reproduce at all, or their lineage dies out somewhere down the line, then from a purely genetic bookkeeping perspective, it looks exactly as if there were far fewer men than women in that village to begin with. The women's genetic contribution stays broad and spread out across many different maternal lines. The men's genetic contribution gets funneled down into an increasingly narrow set of paternal lines. So who were the researchers even looking at when they tried to explain this? A team out of Stanford ran the numbers and landed on a theory that, frankly, sounds like something out of a fantasy series. Their explanation was warfare between patrilineal clans. Here's the setup. As farming and herding spread across the ancient world starting roughly 12,000 years ago, human societies increasingly organized themselves around extended family groups built around male ancestry. Everyone in the clan traced their lineage back through their fathers' fathers, and so on. Women often married into these clans from outside, but the men within a clan were all related to each other through the same male bloodline, which meant they were all carrying extremely similar Y chromosomes. Now imagine those clans start fighting each other over land, water, livestock, whatever resource was scarce that century, and imagine that when one clan wins a conflict against another clan, it doesn't just win a battle. It effectively wipes out an entire branch of the human family tree in one stroke, because every single man in that losing clan was carrying nearly the same genetic signature. Kill the men of a clan, and you don't just kill individuals, you erase a whole unique version of the Y chromosome from existence, permanently, in one afternoon. Do that across a few thousand years, with clan after clan getting wiped out or absorbed by more successful rivals, and you get exactly the pattern we see in the DNA. A small number of surviving male lineages exploding outward, while a huge number of other lineages just vanish. Meanwhile, the women, who typically weren't organized along these same clan-based lines, and who often moved between groups through marriage, kept a much broader and more continuous genetic signal running underneath the whole mess. The researchers actually tested this with computer simulations, running scenarios where clans fought each other, and they found that when they modeled patrilineal warfare, the Y chromosome bottleneck appeared naturally in the simulation. When they modeled conflict between groups that weren't structured that way, where men and women could both move freely between groups, the bottleneck simply didn't show up. It only appeared under the specific condition of male-line clans wiping each other out, which is a genuinely elegant answer. Also a slightly terrifying one because it means an enormous number of human beings, mostly men, were essentially deleted from the future. Not killed in the sense that history remembers. No monuments, no records, just quietly erased from the family tree of everyone who exists today. But here's the thing. Warfare wiping out entire lineages explains part of the story, but it doesn't necessarily explain all of it on its own. And more recent researchers have pushed back on the pure warfare explanation with something arguably even more interesting. You don't actually need constant bloody warfare to produce this pattern at all. You can get the exact same genetic signature through something almost boringly peaceful, which is how clans naturally split apart over time. Think about how families actually grow. A clan gets large enough that it becomes unwieldy, so it splits into two smaller clans. One of those splinter clans happens to have slightly better luck, slightly better land, slightly more sons who survive to adulthood, and it grows faster than the other. It splits again. And again. Meanwhile, some other clan somewhere else just quietly fails to grow at all. Not because anyone killed them, but because that's how random variation works when you're tracking bloodlines over centuries. Some family lines just naturally peter out while others snowball. Run that process forward for a few thousand years with no war involved whatsoever, purely on the mathematics of which lineages happen to expand faster than others, and you can reproduce the exact same collapse in Y chromosome diversity. The paper modeling this used real anthropological data from an actual modern group, the Kipsigis people of Kenya, where researchers already had solid numbers on polygyny rates. And what they found was that in a segmentary patrilineal society like that one, where some men have significantly more wives and children than others purely through the ordinary churn of family fortune rising and falling, You get a bottleneck that looks statistically identical to the warfare model, minus a single drop of blood spilled. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Which honestly might be the more unsettling explanation of the two. It's one thing to imagine ancient warlords slaughtering rival clans in dramatic battles. It's another thing entirely to realize that simple, mundane inequality in who gets to have children, repeated patiently over a few hundred generations, produces the exact same genetic outcome as centuries of warfare. No swords required, just time and an uneven distribution of reproductive opportunity. And that phrase, uneven distribution of reproductive opportunity, is really the heart of the whole video, because it's the actual mechanism connecting the DNA mystery to your original question about how many women the average ancient man actually had. Here's the uncomfortable truth. There was never really an average ancient man in any meaningful sense because the whole point of this bottleneck is that reproduction wasn't evenly spread out at all. A small number of men fathered an enormous share of the next generation, while a huge number of other men fathered very few children or none whatsoever. So if you're picturing some cozy, evenly distributed ancient world where every man had, say, 2 or 3 wives on average, delete that image immediately. That is not what the evidence shows. What the evidence shows is something closer to a lottery with a small number of massive jackpot winners and an enormous crowd of people who walked away with nothing. Let's actually meet some of the jackpot winners because this is where the story goes from abstract statistics to jaw-dropping individual cases. The most famous name in this conversation is Genghis Khan, and honestly, the story around him has become one of those pieces of internet trivia that gets repeated so often people forget to check where it actually came from. Back in 2003, a team of geneticists studying Y chromosome data across a huge swath of Asia stretching from northeast China to Uzbekistan found that roughly 8% of men in that region shared an unusual and nearly identical Y chromosome lineage. Extrapolated across the population, that worked out to something like 16 million living men sharing what researchers proposed was Genghis Khan's genetic signature. The logic behind attributing it to him wasn't just wild speculation. Historical accounts describe Khan's empire as one where harems and concubines were completely normal for the ruling elite, and his own sons apparently followed suit enthusiastically. His eldest son Tochi is reported to have had roughly 40 sons of his own. 40. Not 40 children total. 40 sons. If that number is even roughly accurate, you start to understand exactly how a single bloodline could balloon into millions of descendants within a handful of centuries, especially when that bloodline sat at the top of the largest contiguous land empire that has ever existed. Now, more recent research has actually thrown a wrench into the neat version of this story. Scientists excavated tombs in Kazakhstan believed to belong to descendants of Khan's son Yochi, sequenced their DNA, and found they carried a specific, rare sub-branch of the Y chromosome lineage in question, rather than the extremely common version found across millions of men today, which suggests the wildly common lineage might actually trace back to some completely different, unnamed patriarch who lived roughly 1,000 years before Genghis Khan was even born. So the 16 million descendants claim might belong to someone history simply never bothered to write down, which, if you think about it, is almost a more fascinating twist than the original story. Somewhere out there, some anonymous man who nobody remembers, whose name is lost completely, may have outreproduced one of the most infamous conquerors in human history without anyone ever putting his face on a coin or a statue, and Genghis Khan isn't even close to alone in this club. A 2015 study analyzing over 5,000 men across 127 populations in Asia identified 11 separate Y chromosome lineages, each shared by dozens of the men sampled, meaning each one represents a single ancestor whose bloodline exploded across history. One of them belongs to Jiokanga, grandfather of the man who founded China's Qing dynasty, and his lineage alone is linked to something like 1.5 million men in modern northern China. Almost certainly through the same mechanism, his descendants inheriting both power and a small army of wives and concubines. 9 of the other lineages remain completely anonymous. Nobody knows who they were. They just left behind unmistakable genetic footprints stretching from roughly 2100 BCE all the way up to 700 CE, scattered across a continent with zero written record of who they actually were. And it's not just an Asian phenomenon either. Over in Ireland, a 2006 study found that roughly 1 in 12 Irish men worldwide can trace their lineage back to a single individual, potentially a 5th century warlord known as Niall of the Nine Hostages, who may have as many as 3 million direct male descendants walking around today. 3 million people, all tracing back to essentially one guy who lived over 1,500 years ago and apparently took the concept of spreading his legacy more literally than almost anyone in recorded history. So when you zoom out and look at the pattern across completely unrelated regions of the world, Mongolia, China, Ireland, you keep finding the same basic structure. A tiny handful of exceptionally successful men, usually sitting near the top of some power structure, whether that's a warband, an empire, or a chiefdom, produced an outsized share of all future generations, while the vast majority of men around them contributed comparatively little or nothing at all to the gene pool going forward. Which brings us back to the actual number in the title, because now we can finally answer it properly instead of just throwing around a scary statistic. If you're asking how many women the literal average ancient man had, in the sense of just doing simple division, the answer is going to hover somewhere close to 1, because population sizes were roughly balanced between men and women, and monogamy or something close to it was almost certainly the practical norm for the majority of ordinary people throughout most of history, purely because most societies simply didn't have enough surplus resources for every man to support multiple wives and their children. Feeding one family was hard enough for most farmers, herders, and laborers. Feeding several was a luxury reserved for people with actual wealth or power. But if you're asking a slightly different and more honest question, which is, what did the distribution of reproductive success actually look like across ancient male populations? The answer is wildly different, and it's a much better question because it's the one the genetic evidence is actually answering. In that framing, the picture looks less like everyone getting roughly the same slice of the pie and much more like a tiny elite hoarding the vast majority of the pie while a huge number of men got crumbs or nothing. There's actual anthropological data backing this up beyond just the ancient genetic record, too. Studies of societies practicing polygyny, meaning multiple wives per husband, have found some striking figures. In certain patrilineal societies, some men have been documented having as many as 12 wives, and in those same societies, researchers have found that something like 83% of women end up sharing a husband with at least one other co-wife. That's not a rare fringe practice tucked away in some remote corner of anthropology. That's describing a system where polygyny is essentially the default expectation rather than the exception, and where a smaller pool of men are accumulating disproportionate numbers of wives, while other men in the same society may struggle to marry at all. And once resources, power, and status get concentrated at the top of a society, whether that's ancient Mesopotamia, dynastic China, the Mongolian steppe, or plenty of other historical civilizations, that concentration tends to translate directly into reproductive concentration too. Kings had harems. Wealthy landowners had multiple wives and concubines. Warlords who conquered territory frequently took the women of defeated populations as spoils of war, which historians have documented across an uncomfortable number of ancient conflicts throughout different continents and centuries. Meanwhile, the poorest men in those same societies, the laborers, the slaves, the lowest rungs of whatever hierarchy existed, often had drastically reduced chances of marrying or reproducing at all, sometimes through no fault of their own beyond simply being born without money, land, or status. This is one of the more sobering aspects of ancient history that doesn't get talked about enough. We tend to imagine the ancient world through the lens of kings and conquerors because those are the stories that got written down, the statues that got carved, the tombs that got preserved. But the genetic record is telling us something the history books mostly left out. An enormous portion of ordinary men throughout history simply didn't get to participate in the next generation at all. Not because they died young necessarily, though plenty did that too, but because the reproductive opportunities in many ancient societies were funneled disproportionately toward a small number of powerful men at the expense of everyone else, which actually flips the entire premise of the video's title on its head in a really satisfying way. The question, how many women did the average ancient man have, almost implies there's a nice, tidy, evenly distributed answer waiting for us, something we can attach a clean number to and move on. But the real answer is that average is doing a lot of misleading work in that sentence. Because averages are famously terrible at describing situations where a small number of extreme outliers are dragging the whole statistic in one direction. If you average the wealth of everyone in a room that happens to include a billionaire, you get a number that describes almost nobody in that room accurately. Ancient reproduction worked exactly the same way. A small number of Genghis Khans, Geokangas, and anonymous conquering patriarchs dragged the statistical average upward, while the actual median experience for a typical man was closer to one wife, if he was fortunate enough to marry at all, and possibly zero children who survived to adulthood given the brutal infant mortality rates of the ancient world. There's a darker implication buried in all this too, one that connects directly back to why the Y chromosome bottleneck matters so much beyond just being a cool piece of trivia. Every single one of us alive today only exists because we happen to be descended from the winners of that ancient reproductive lottery. Every man whose lineage got wiped out in a clan war, whose family line simply failed to expand while a rival clan boomed, whose social status left him unable to marry at all, contributed absolutely nothing to the roughly 8 billion people currently occupying this planet. Their genes are gone, not diluted, not merged into the modern population somewhere, just entirely absent, as if they never existed. Which means that if you're watching this video right now, statistically speaking, you are descended from someone who was on the winning side of that brutal ancient calculus. Somewhere in your family tree, going back far enough, is a man who managed to out-reproduce the vast majority of his contemporaries, whether through power, wealth, conquest, sheer luck, or some combination of all four. That's not a comforting thought exactly, but it is an undeniably fascinating one, and it's the kind of thing that completely reframes how you look at ancient history the next time someone mentions harems, conquest, or dynasties in passing. So to bring this all the way back around, the average ancient man in the strict statistical sense probably had close to one wife because most of history's population was ordinary people living ordinary, resource-constrained lives where supporting multiple wives simply wasn't realistic. But the actual lived experience of reproduction across ancient societies was anything but average. It was a landscape dominated by a small number of extraordinarily successful men, sitting on thrones or leading war bands or controlling vast tracts of farmland, who fathered a wildly disproportionate share of the children who would go on to become all of our ancestors, while a huge, largely invisible population of ordinary men either had one wife, or no surviving lineage at all. The 17-to-1 ratio buried in our DNA isn't describing a strange demographic anomaly where women outnumbered men. It's describing the fingerprints of that inequality, preserved for thousands of years in the quietest, most permanent record humans have ever left behind. The twisting, branching, occasionally brutal story written directly into our own genetic code. And honestly, that's a much stranger and more interesting answer than any single number could ever have given you.